Actually on day 18 of Algebra 2. And our do now is this worksheet here where we're solving absolute value equations. Again, it is Tuesday. I'll write the date down. Tuesday, November 4. Okay, and yesterday we learned about absolute value and what it is. Can anybody remind me, what is absolute value? What does that describe? Anyone remember?
Distance from 0 on a number line.
Yes, it's the distance from 0 on a number line. So looking back at that guided notes page, that's what absolute value is. It's the distance from 0 on a number line. The absolute value of a positive number is positive. The absolute value of a negative number is positive. You will always have a positive number unless we want to add a negative on the outside of it. It's like we have a negative after we find the absolute value. We'll see more examples like that. So looking at this worksheet, I see now we have absolute value in equations. And we'll start by just looking at number 1 here. If I can focus it. Come on now. Okay, so for number 1, I have the absolute value of 8 plus 7x is equal to 34. When there is absolute value involved in an equation, what is the first step I need to take before I can start solving?
The brackets or the parentheses.
Look at my brackets, my parentheses, my absolute value bars. What do I have to do with my equation, or what do I have to make sure of first?
You start in the brackets, right?
You do start by looking at those brackets. You guys are right.
You want to get it 7x by itself.
You want to get 7x by itself, but not
the whole
just
thing by itself.
Yes. If you look again on the back side of that notes page, when you want to solve an equation, the first step is to isolate the absolute value expression. Basically, that means get the absolute value by itself on one side of the equal sign. So for number 1, do I need to do anything to get my absolute value by itself?
You separate them into positive 34 and negative 30.
Yes, I do that once I have that absolute value by itself. Now, can I go ahead to that next step? Is the absolute value by itself?
I mean, you can, negative 8 or minus 8 from both sides.
Well, you're right. We are going to do that. But I guess the question that I'm asking, and maybe I'm not asking clear enough, is, let's see, this 8 plus 7x is what is inside the absolute value bars. Here's my equal sign. Is there anything else over here with 8 plus 7x? Nothing. So it's by itself. Step 1 is already done.
Get rid of the bars.
Yes. So for step 2, that's where we create 2 equations. And we're going to make one positive and one negative. And we'll drop the bars. So we'll start here. What should I write for my first equation?
8 plus 7x equals 34.
Good. 8 plus 7x equals 34. That's my positive equation. What do I write for my negative?
8 plus 7x equals negative 34.
Yes. 8 plus 7x equals, we just changed the answer, negative 34. So we get rid of the bars. We make one of our 34s positive, one negative. And now we solve both. So, Lewis, you were saying we would subtract 8 from both sides. Let's go ahead and do that. Minus 8, minus 8. And then what comes down over here?
And got your 7x.
7x equals
26.
26
Divided by 7.
divided by 7. And we get x equals
3.71.
3.71. Yeah, we'll get some decimals.
There is because decimals.
I know the decimals
There's a couple decimals
really
on
trip
the
us
sheet.
up. And it's a little, I don't like decimals either.
There's a couple of them. I think there's 7.
Okay. So, yep, so I got, it is a funky decimal too. It's not a nice pretty one. So,
Yep, that's it.
you see our last step, we did 26 divided by 7. That's going to give us 3.714285714. Just do the first 2 decimals or so. You can do 1 decimal or 2. You can write them all if you want, but I really don't need all that. I'm going to write 3.71. And that's my first value for x. Right there. 3.71. So let's go ahead and solve the negative equation now. What's my first step again? Subtract 8 on both sides. Yes, you can.
You have a plus sign on both sides.
Why do I have a plus sign on both sides? Right here?
Yeah.
So whenever we separate the equations, whatever is inside the absolute value bars, we don't change that. So we will keep that as 8 plus 7x for the positive one. We'll also keep it as 8 plus 7x for the negative one. The only thing that we're changing is, let me use a different color to show it. We're only changing the answer, 34. So for my positive equation, I keep positive 34. For my negative equation, I change it to negative 34.
That's what I kept
Yes.
about.
That's the only thing we change when we do 2 equations.
So that's awesome.
Yes.
And I couldn't click in my head.
That's all right.
Now.
Hey, sometimes it just takes a couple of times and then it just clicks.
Yeah, I know.
That's good. I appreciate you asking that because I bet you're not the only one that was wondering.
Oh, my goodness.
So,
You did.
what's
Yes.
extra in my brain this early?
Oh,
my goodness.
All right, so we subtracted 8 from both sides. Now we need to be careful. We're not doing 34 minus 8 again. It's negative 34 minus 8.
So you turned it into a negative.
Yes.
Oh, wow.
Yes. For our negative equation.
But that's a subtraction to 8.
It
Wow.
still is, yes. So go ahead.
I was gonna ask. Okay, basically what you just said is what is inside of the absolute value bars.
Uh-huh.
This plus or negative, well, adding or subtracting. That's how we know what to subtract outside of that to make it positive and negative equations.
Can you ask that one more time? Repeat that for me.
Like how you got the arrows pointing from the positive sign. That's like letting us know that, like you said, that stays the same on both sides.
Mhm.
What's outside of the equal sign is what's positive and negative.
Yes, I think me drawing arrows from here is confusing. Let me do this. It's the 34 that changes. Let me actually, hang on. Let me be more clear with what I'm writing.
I mean, it makes sense now that you just said that.
Yes, but for people, I know there's a few of us that weren't here during the very first lesson, so I want to be very clear to make sure what I'm doing makes perfect sense. I appreciate you asking that. So I'm going to rewrite this problem. 8 plus 7x equals 34, and absolute value of that. What we're doing whenever we split the equation into 2, we are just changing this into
Positive and negative.
positive 34 and negative 34. This stays the same. So, if it helps, let's kind of color code all of it.
Yes.
I'm going to bring this down. 8 plus 7x. This doesn't change.
Just don't keep your bars.
Equals, yes, we drop the bars. And then we bring down 34. We'll keep it the same for 1. My second equation will be same thing, 8 plus 7x equals, and now it's the 34 that changes. We'll do negative 34. Okay. So this is the positive one. This is the negative one. Does this make a little more sense?
Yeah.
Yes.
Good,
I think I
good.
would just put the positive sign on there so it goes
Yeah.
positive and
Because
negative.
like you said, I mean, everything inside the absolute value bar stays the same.
Yes, yes.
addition sign is what gives us the clue for it to be outside of that, making
Yes.
two separate equations.
Absolutely. So that's all that I'm doing when I write plus and minus is I'm saying this is where I keep 34 positive. This is where I change it to negative. So, and is that answering the question you were asking? No.
Yeah.
Okay. Perfect.
Because I
Okay.
be too busy second guessing myself sometimes.
Oh, I get it. I
Just like
totally
the
get
decimal
it.
answers, I'm like, am I not doing something right?
Yes. Here, Emily, this is what we're looking at.
Thank you, sweetie. Yeah.
Okay, and so let me
You know
finish
what?
rewriting this here. So we solved the positive one.
Good.
We did minus 8 on both sides. I'm just rewriting what we've already done. And we bring down 7x equals 26. And then we divide it by 7. And we got x equals 3.71. That's what we got for the first one. So I'm just rewriting that. Okay, so now that I've written things a bit more clearly, let's go on to solve the negative 34 equation. So we started the same way. We subtracted 8 from both sides. That leaves us with 7x equals, and now here's where we stopped. So now what comes down on the other side here?
Negative 42.
Negative 42. Good. Okay, so now what do I do?
Divide both the 7.
Yes. Divide both sides by 7 to get rid of it and give me x by itself equals negative 6. Good.
And see what got me too, real quick?
Mm-hmm.
By second guessing myself, I don't know why, but I was making the positive side positive where you're dividing.
Uh-huh.
And on the negative side, I kept putting -7. Like, I don't know why.
I gotcha. I wonder if you were wanting to change the plus inside to a minus. Is that what you did?
Yeah.
Okay, so you were wanting to change the whole thing negative.
Yeah.
I had got confused with thinking everything on the positive side
Yes.
be positive and everything on the negative side be negative.
That makes sense.
So
That
that's
makes
what-
sense. Yeah, so we're just changing what's after the equal sign, outside of the absolute value. Good. Good.
The same thing.
I said I'm gonna put that back. Well, good. I'm glad we talked about it then. That helps.
Uh-huh.
So off to the side here, now that I do have my answers, if I wanted to graph these answers, I'll just do a little graph over here. Yeah, we forget about the graph. That's all right. So on my graph, which one of these numbers would come first?
The -6.
The -6. A -6 is smaller than a positive 3.71. So we'll put a tick mark. We'll put -6 first. Make sure that you put a little point on that tick mark. And then we'll do another tick mark, put a point on it, and I'm going to write my other answer, 3.71. And that's it.
So, okay, that's 8 plus 7x equals 34, the original question.
Yes.
To make that true, it has to be -6 spots away from the 0, or a 3.71 on the positive side away from the 0.
Yes. We just found what numbers we could plug in for x.
Okay.
And this should be true. So we could check these answers, make sure they make sense.
No, we're good. We ain't got checked nothing. I promise you.
Oh, man. Y'all are too much. Too much. Okay, and if we want, we can check. I'm not going to check it by plugging it back in, but I'm going to look at
I
the
didn't
answer
say
key.
nothing.
My answer key tells me that for number 1, we should have gotten 26 over 7. They kept it as a fraction,
Okay.
which 26 over 7 is how we got 3.71. So perfect. We did that. And -6 was the other answer. So we did it. Yay! I'll circle my graph. That was number 1.
Winning.
Cracks me up. Okay, let's do another one of these. Let's look at, how about number 2? And I'm going to continue writing them on a separate page. It gives me a little more space. So for number 2, let's copy down the problem. Absolute value of 7x plus 8, absolute value, equals 57. Okay, so here's number 2. So first thing we should ask ourselves, we have 2 sides of the equal sign. Everything that's in the absolute value, is it by itself on that side of the equal sign? Is there
Yep.
anything no, yeah, it is. It's by itself. There's nothing I need to get rid of. There's no plus something on the outside. There's no number being multiplied outside.
That's what I'm gonna get.
So what do?
Get rid of bars,
Mm-hmm.
bring them down to 2 separate columns.
Perfect. We're going to bring this down, what's inside the bars,
Yeah.
into 2 separate equations. My first one, don't change anything for 7x plus 8.
Except removing the bars.
Yes, just remove the bars. 7x plus 8 equals, what should I write for my first equation?
57, a positive. Yeah.
57. So here's my first equation. There's my positive 57. For my second equation, what should I begin with?
Same, without the bars. Same
Perfect.
equation.
Same thing without the bars. 7x plus 8.
Equal negative.
Good. Equals, the only thing that changes is the answer. Negative 57. Good. Yeah, I'll tell you what. Colors help a lot. It's making me a little more organized this
I
morning.
think this is what separates you from other teachers, though.
Oh.
Being able to stop, slow down, and break this down for everybody like that.
You're so sweet. I try.
A lot of teachers don't do that.
Well, that's what I had to do. Whenever I was learning this kind of stuff, if I didn't slow it down, I wasn't going to understand it enough to teach it to you. So
Yeah.
I got to slow it down for myself and for you guys.
I can actually look at my notes and understand them
Right.
now.
Right.
Compared to before, I was like, what did I even write?
Okay, so we have split our equation into 2 equations. Let's solve the positive one first.
Okay, subtract 8 for both sides.
Good. Subtract 8 from both sides. And let's see. That brings down 7x equals 57 minus 8 is 49. Good.
Divide 7 on both sides.
Perfect. Divide 7. And we get x equals 7. Very, very nice. Pause this real quick. Okay, so we just found our positive equation answer. So now, yes, that one. Now let's do the negative one. Draw a line. Yeah, we're gonna do the same exact thing. Subtract 8 on both sides. But now we're doing negative 57 minus 8.
Negative 65.
Negative 65. Bring down 7x. Divide by 7.
Negative 9.28.
You got negative 9.28?
Yep.
Negative 9.2.
Okay, so let's see.
Tell me one.
Negative 65 divided by 7. Yep, I got negative 9.285714286. I know, that's not a pretty one. But we can put 1 or 2 decimal places. You could write negative 9.2, negative 9.3 if you round up. You could do negative 9.28 if you round up, negative 9.29. I'm not going to be picky on your decimals.
Yeah, I was gonna
Or
say,
they
would
leave it
you
at the
accept the
other.
9.3?
Yes,
If
I
somebody
would.
rounded up?
I would absolutely accept negative 9.3. I'm gonna do 2 decimal places, so I'm
Yeah.
gonna look at 2, 8. The number after 8 is 5, so do I round up or no? I do. I'm gonna write negative 9.29.
Negative 9.29.
Yes. If you put 2, 8, it would not be wrong. I won't be picky. But I'm gonna do 2 decimal places and I'll round up. So there's our 2 answers. And if I were to graph, let's do a little graph. I'm going to put my 2 tick marks, 2 points. Which number comes first?
Negative 9.2.
Yeah, negative 9.29. The negative number is always smaller. And then 7. Oh. Good. You're good.
Right, boys, I think I've got
It's so cute. Okay, so we've just done 2 of these problems where the absolute value expression, the stuff in the bars, was already by itself. Why don't we look at a few problems on the back? Make sure we remember what to do when it's not by itself. These can be tricky. How about we start right with number 11? Let's look at number 11. I'm gonna write that problem.
Ooh, this is ugly.
It's ugly, but we can do it.
Yeah,
I
okay.
think I've got this.
So, number 11, we have
Man,
10 plus 9. And then right next to the 9, we have an absolute value bar. And inside my absolute value, 6 minus 7x. Close my bars. Equals 82. So this is a little tricky looking.
but we subtract 10 from both sides and then divide that 9. Okay.
So we still working from the inside.
So
I'm jumping too far.
we want to get to where we can work on the inside parts, but let's start. Go ahead. Go.
So we're gonna do first 2 first.
First 2. What do you mean the first 2?
The 10 and the 9.
We are.
Okay.
Yes. So I'm looking at this equation, and what I'm going to do is I'm going to kind of label it similar to my last problem. What's inside my absolute value bars?
6 minus 7x.
6 minus 7x. I'm going to underline that. On the other side of my equal sign, I have 82. But is my absolute value expression by itself?
Nope.
No, so I cannot split my problem yet. First, I need to get rid of this 10 and this 9. So before we do that, let's talk about what each of these numbers are doing. This 10 is
Oh,
being
by itself.
added.
Yeah,
Yep,
it's
it's
all
by
by
itself. So this is 10 plus all of that. What's happening with this 9?
It's chilling right up against that bar like a villain, and needs to be fighting.
It is chilling like a villain right up against that absolute value bar.
Yeah.
So, what operation is happening? When I say operation, I mean, is it being added? Is it being subtracted? Is it being
It's
multiplied?
multiplying, but
Yes.
we can do the opposite.
This means 9 times the absolute value. So, if you last time I taught this, I had a lot of students forget that when a number's right next to it, it means it's being multiplied. This is a good little side note to make if you think you may forget this in the future. If I have something like this, 9 absolute value, 6 minus 7x. This means 9 times 6 minus 7x. Put that in parentheses. This is multiplication. to get rid of multiplication, we divide. We do the opposite. So we could write in parentheses here, divide to get rid of 9. Anytime we have a number outside of absolute value and there's no symbols in between, it's just sitting right up there, it's multiplying. It's multiplying.
That 9, man, is up there like chilling.
Yes. So,
Get him out of there.
Wait, I'm confused.
sure.
So, we would just times a 9 times a 6, and we wanna do 9 times 6 times 7?
So what's happening here is, if I'm ignoring this 10 for a minute, this 9 is being multiplied by this whole thing. But we're not going to actually do that. We're not actually going to do 9 times 6 and 9 times minus 7x. We're just going to know that this 9 is being multiplied because we're going to need to get rid of it. So to get rid of it, we do the opposite of multiplying. We're going to actually end up dividing it.
Because whenever you divide it, you get rid of the 9 and cancel.
Yes. So this might start to make a little more sense when we actually
Yes,
get rid of the
I'm
10 and the 9. Let's do that. I'm going to put this sticky note over to the side for a moment. And stop me as soon as you don't understand, please. I want to make sure we get it. So first we need to get rid of the 10 and the 9. I'll use a separate color here for step 1. So which one should I get rid of first?
The 10.
The 10. Because the 10 is not attached to anything. It's all by itself. Let's do that first. It's a positive 10. How do I get rid of a positive 10? Yeah. Subtract 10, negative 10. So minus 10. Where else do I subtract 10?
From your 82.
From 82. We do it on both sides. Okay, so what happens?
Bring down your 9,
Mm-hmm.
positive 9, absolute value bars of
That's
6 minus 7x,
Mm-hmm.
then equals the 82 minus 10, 72.
Perfect. Okay, so what just happened here is we subtracted 10 from both sides, and we just brought everything down. And now we're still trying to get what's in the absolute value bars by itself. Is it by itself yet?
No, divide by 9.
Yes, so this is where it's important to know that this 9 is multiplication, because to get rid of the 9, we need to know what that is so I can get rid of it. This is why we will divide by 9. So we're going to divide this side by 9. What else gets divided?
The 72.
The 72. Okay, so what happens over here?
The 9s cancel out.
The 9s cancel. And what comes down?
Your absolute value or 6 minus 7x.
Absolute value, 6 minus 7x equals
8.
72. Yep, 8. 8. Good. So I'm going to make a little side note. This was step 1. We want to.
Actually, in reality, did nothing change?
Nothing
divided.
inside the absolute value changed. Nothing of that changed. Absolutely, you're right.
Okay, you just brought the 9 down. It said divide, but you really didn't divide anything.
We did divide this 9 because what
Into the
happened?
72.
Yeah, we divided by 9 here to get rid of this 9.
So you divided 9 into 9?
Uh-huh.
Uh-oh.
Yes, so that's why they canceled. Because we have 9 times 6 minus 7x. If I divide by 9, it gets rid of it.
Yeah, because yesterday when you did that with this problem, yesterday, and
Uh-huh.
I kept saying, what she dividing her two into?
Uh-huh.
And I
Same
kept
thing.
thinking she didn't do anything with that.
Right.
So,
We just got
okay.
rid of that number on the outside. It's kind of the same thing as, like, if I have, let's see, 2x equals 10. If I want to get rid of this 2, just like here I wanted to get rid of 9, we divide by 2. And we're not going to change the x, just like we don't change what's inside the bars. We get rid of the number on the outside and just bring what's inside down. That's what we did here. It's just we have more things attached to that x because of the absolute value. Does that make sense?
It makes sense now.
Perfect. Okay, so that was step 1. We isolated the absolute value. We got it by itself. Now let's look at what we have left. What's inside my bars?
The absolute value
Yep.
by itself.
By itself. And now the number by itself on the other side is 8.
Okay.
Now what do we do?
Plus
Get
and
split it
subtract.
this time.
Yes, now we split. Okay, so this is step 2.
Yeah.
Split into 2 equations.
I know, I wonder. Whenever you split them up and you start doing the,
Breaking it down.
no, not the breaking it down, whenever you break down the 7x,
Mhm.
is that gonna make it a negative 7x because of minus sign?
Yes. Like when you get rid of the 6, that negative
Yeah.
will still be there, yes. So let's write our 2 equations. My first one, what do I begin with?
6 minus subtracted by 7x.
Yep.
Right?
We still have 6 minus 7x equals 8.
Then on the other side, you put 6 subtracted by 7x equal negative 8.
Yes. Only thing that changes is the 8. Positive 8, negative 8. And I'm going to put an equal sign in there.
Do the math.
Equals.
Now you like.
Yeah, I'm going to draw a little line. Draw my line.
That's the haymaker, man.
Okay, so I have my equations. What should I do first over here for my positive 8 equation?
Plus 6.
Minus 6.
Ooh.
Oh, minus 6.
Yeah, so why are we going to subtract 6 instead of adding?
Oh.
It's outside.
It's a positive 6. If I add 6, that's not going to get rid of it. It'll become 12. I need to subtract 6 so
Right.
that it's 0.
Because that 7x is close to that line.
Mm-hmm.
Because, yes.
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 We got to get rid of the numbers by themselves. So minus 6 on both sides. And what comes down?
Negative 7x.
Negative 7x equals
2.
2.
2. Okay.
Can you divide both sides by negative 7?
Yes. Divide both sides by negative 7.
It's going to
It's going to be a funky number, but that's okay.
Yeah, that's where I thought I messed up
Nope, you
at
didn't.
first.
You sure didn't. So now we get x equals.
Negative 0.28.
Ooh.
be.
Yes, negative 0.2857142857. Ooh, it looks like it's repeating. 2857. See that twice.
There or what?
I'm gonna round. I'm gonna do 2 places and do negative 0.29. Yeah. So negative 0.29.
know what it's song off in my head. Remember this song on
Yeah.
Hey, we got our positive equation answer. Negative 0.29. What now?
Alright, let's go to
Do it again.
Do it again. Okay, so how do I start?
Minus 6 on both sides.
Minus 6 on both sides.
Gives you negative, well,
Yep,
yeah,
yep.
negative
still
14.
Okay, Minus 6, negative 14.
And divide by -7.
Mm-hmm.
X equals 2.
X equals 2. Perfect. If I graph it,
-0.29 will go first.
yes, negative 0.29 is the smaller one. That will go first. And then positive 2. Very nice.
That's a lot.
Yes. Yes, it gets trickier when you have to get that absolute value by itself first. That's where they start taking a little longer. We're gonna do more practice with this too.
I almost have to stop myself because when I get to the 6 minus 7 x equals 8 part, then I want to keep going and -6 from both sides. And I want to keep going like I am on the left and try to get one answer and like gotta stop myself. Oh, I'm trying to do this twice.
Huh.
A positive and negative. So
Right.
yeah. I've stopped myself twice doing that.
I think that's one of the hardest things about math in general is when you start feeling like you know what you're doing, you want to just go, go, go,
Yeah.
and then you make a silly mistake because you're not being slow with it.
Yeah.
We gotta be slow, intentional, careful. That's the hardest thing is to slow yourself down.
Fast.
No need to rush anything. Leave this here while everybody finishes copying it down. And then we're gonna do number 12 next. If you're wanting to take a peek at it before we start, number 12 is what we're doing next.
So, you want us to do the graph part after we, like, always do the graph part after we solve the equation?
Yes,
Okay.
yes. And I know I didn't give you any graphs on this worksheet, but luckily that graph is just a quick little
Just to
extra
be in
thing.
a little habit of it.
Yep, just to be in the habit of it so that we can kind of practice remembering those negatives are smaller. And because eventually we will be using X and Y values, but not yet. Not yet. We're just doing X's right now.
So, just asking technically after we did the first two steps, the last step will be to graph it.
Yeah, so step 3 could be graph. So step 1, isolate absolute value. Step 2, split into 2 equations and solve. Step 3, graph your answers. Anybody still need to see number 11 before we try 12? You got that? I don't want to move it if you're still using it. Go ahead and scooch this paper. Stop me if you need it. Okay. So, flipping my page, and now I'm going to write number 12 here. And
I know.
for number 12, we have -2 plus 2 times the absolute value, 1 plus 9x, close the absolute value, that's equal to 50. What do I have inside of the absolute value bar?
1 plus 9x.
1 plus 9x. So we don't want to touch that. We want to get rid of everything else. So what should I get rid of first?
Your -2.
That -2. How do I do that?
Add 2.
Add 2. Plus 2. Where else do I add 2?
On the 50.
On the 50. Good. Okay, so what comes down?
Positive, yeah, plus sign two.
So we've got 2. Do I really need to bring the plus sign down?
No,
No, we don't. If I bring that plus sign, you can just to show it's positive, but what I would worry is that you might see that plus sign and think, oh, I'll just subtract 2 again, and that'll get rid of it. But it's not addition. We got multiplication there. I'll bring down absolute value of 1 plus 9x equals
52.
52. Good.
you're gonna divide both by 2?
Good. Now we want to get rid of that 2 on the outside. We will divide by 2. And that doesn't change anything inside the absolute value. It just gets rid of the 2 on the outside. So we bring down absolute value of 1 plus 9x, close the value. That equals what?
26.
26. Okay, so I'm going to write over to the side that we just did step 1.
So definitely give me my job.
Isolate
But
the absolute value. What should I do next?
What are the 2 equations?
Split into 2 equations. What should those equations look like?
1 plus 9x equals 26.
Mm-hmm.
And then 1 plus 9x equals negative 26.
Perfect. So the 1 plus 9x does not change. That's the answer at the end. Okay. So now what?
Subtract 1 on both sides.
Yes. Subtract 1 on both sides here. Bring down 9x equals
25.
25.
Divide by 9.
Divide by 9.
decimals.
Decimals. Okay. X equals.
I said 2.7.
777.
Okay, let's see what we get. 25 divided by 9. Oh, yes. Okay, we get a repeating decimal. So, quick review on how we write repeating decimals. If you get something like this on your calculator where it says 2.7777 and then there's an 8 at the end, your calculator is just rounding up to 8. This is actually sevens forever. It goes on forever and ever. When we have a repeating decimal like this, we just write, yes, 2.7, put a line over the top of 7 to show that it's repeating.
Okay.
If you don't do that, you're not going to get it counted wrong.
Oh, you just
But-
taught me something new today.
Well, there you go.
No, I
Repeating
didn't know that.
decimals, you put a line over it. Okay.
So yeah, when that number keeps going like that, all you do is put a line over the
Yep,
top.
that's it. Then you don't
That's
have to
neat.
write it a bunch.
That's neat.
Absolutely.
That's cool.
Okay, so we did our positive equation.
Yeah, I didn't know that.
Let's do the negative.
I went back where I actually was in school.
What do I do over here?
Minus 1 on both sides.
Minus 1 on both
I
sides
just didn't
again.
do it in my answer.
Millennia ago, right?
Yeah.
I'll bring down my 9x equals
Negative 27.
negative 27. Good. We'll get a better answer here.
Divide by 9.
Divide by 9.
X equals negative 3.
X equals negative 3. Yes.
That's more like it.
Yes.
I know.
Okay.
Yeah.
Step 3, let's graph. Which number goes first?
-3.
Good. -3. I know 2.7 repeating looks smaller, but it's positive. So it's actually bigger. So -3 goes first, and then 2.7 repeating. Here we go. Very good. Number 12. Oh, I see a tricky one that might be a good practice one. Let's look at number 17.
Oh,
next.
the devious one.
Yes, let's look at 17 next. That one looks tricky.
What's the name?
I'm gonna write number 17 on my paper.
That was just so devious.
We have -5 minus the absolute value of 5 minus 7x.
Wouldn't that make the whole equation negative? Or do you get rid of the 5?
Well, let's see. Let's see what happens. Let me write the whole thing first. Minus 21. Wow. Okay. So, when you say we get rid of that -5 at the beginning, will it make the whole equation negative?
Well, then 7's already negative anyways, but wouldn't it make the other 5 negative?
Let's get rid of this -5 first and see what we have to do. Let's see what we have to do. So we're trying to get rid of everything outside of the absolute value. What's inside the absolute value?
5 minus 7x.
5 minus 7x. Should I ever change inside the absolute value?
No.
No. So we're not going to touch it. We're not going to touch it. We're going to get rid of everything else, though.
Okay.
So what do I get rid of first?
Add 5.
Yes. We have -5 right here. Let's add 5. Add 5. That will get rid of it. Now be very careful when you bring everything down. What comes down?
Negative sign.
There is a negative sign there.
There ain't nothing there, so I mean.
Negative absolute value 5 minus 7x absolute value equals -21 plus 5.
-16.
-16. Okay.
So what? I mean, is that 0 or There's nothing there.
There's nothing there.
That's stressing you out, Louis.
There's nothing.
I need an X, I need a 1, I need something.
There's
Yeah.
nothing there.
Could you put it imaginary
Over here,
for funsies?
Could you put an imaginary 1 for funsions?
Oh wait,
But there ain't no 1 there. If
It's
they
not
wanted a 1,
one.
they would have put a 1.
So let me ask you something. Let me ask you this.
Louis, I missed you. I'm
I'm
about to sit at the pumpkin table.
Oh.
Let me try something here. If I have, so remember, we're not gonna change what's inside the absolute value. Let me show you something similar. What if I have negative?
You ain't trying to confront this nothing, are you? Leave me in suspense.
We're gonna confront it. So if I have a negative on the outside, and then I have, let's say this is like my x. Negative x equals negative 16. We're gonna replace all of this with x. Okay? So this is what we're looking at. If negative x is negative 16, how would I find positive x? What is really happening here?
You make the minus sign a plus?
We want to make that minus sign into a plus. How do I do that?
Add x.
If I add x to negative x, I'll get 0. Because this is like negative 1x. Divide it by what? Divide by positive 1. Well, a negative divided by a positive is still a negative. What could I do to make it positive?
Ask the question one more time.
If I want this negative x to turn positive, what can I do to change a negative to a positive?
Divide by a negative.
You can divide by a negative. You could also multiply by a negative.
Anything by another negative.
You could. So guys, do you remember back when we were doing elimination and we would multiply whole equations? And I would say like, what if I multiply this times -1? What happens?
That would turn into x
That turns into x
equals
equals
16.
positive 16.
Oh.
Oh,
Wow.
so I can't have a negative here. To get rid of a negative, we multiply by a negative, or you can divide by a negative. Either one works. Okay, this is just like saying -1 times this. That's what that is. To answer that in a roundabout way, this is like -1 on the outside.
Okay.
Louis, she was right.
So if I want, I can rewrite this again. -1 outside of absolute
Then
value.
you should just put the 1 there.
They want you to know because they're not gonna write a 1 there. If there's a negative on the outside, you can think of it as -1. Okay? Think of it as -1.
Jeez.
Now how do I get rid of -1? Is that
You
easier?
divide by negative one.
Divide by -1. You could do that. Let's do that. Okay, divide by -1. Both sides. And what happens? They cancel, don't they? Yes. Now what's left?
Positive 16.
Positive 16. Bring down my equal sign. What's left over here?
Negative.
Did I change this?
Oh no, so just bring it down.
Just bring it down. 5 minus 7x. We never change what's in the bars.
Until the final.
Even in the final solving.
Oh,
Well, when we
take
start
away the
getting rid of
bracket,
stuff.
then you see
Yes, yes. Okay. Before we split, do we need to talk about what happened here anymore? Are we confused about it?
we need to talk?
No, that's straight. Now I know it's a 1.
You okay?
They're lazy butts just didn't write it in there.
Okay.
I thought it was a 1 too. Like what? Because
I should have figured that though, knowing math. I mean,
That's all right. Good reminder. So, is my absolute value expression isolated? Did I get it by itself?
yes.
Yes. Now what?
split it.
Split it. Okay. And what will I be writing for my first equation?
Positive 16 on
Mm-hmm.
5 minus 7x.
Good. 5 minus 7x equals positive 16. And my other equation?
Minus 7x equals.
Yes. 5 minus 7x is now negative 16. Okay, let me write my equal signs.
Okay, since it's over there, we do.
So now we have 2 equations we can solve. Okay. What should I do?
Subtract 5 on both sides.
Yes.
Yes, subtract 5 on both sides. And what comes down?
Negative 7x.
Negative 7x equals
11.
11. We'll get another decimal here.
Divide by negative 7.
Divide by negative 7.
X equals negative 1.57.
And x equals 11. Divided by negative 7. Let's see what decimal I'm getting. Yep, negative 1.57. It's giving you a lot more decimals than that. I'm going to go with the first two, 5, 7. So x is negative 1.57. Okay. What should we do now?
Same thing, -5 on both sides.
Good, same thing, -5 on both sides.
Bring down your -7x.
Bring down -7x. What is that, 21?
-21.
Good, we'll go for the answer.
Divided by -7. It equals 3.
Yes. Divide by that -7 and x equals +3. Wonderful. Okay. Okay. Last step.
Graphing.
Put it on a graph. One comes first.
-1.57.
Good. -1.57 and then 3. Amazing. Really good, you guys. The more we do, the easier it gets.
Mhm.
How it works. Awesome. Awesome. Okay. Well, it is 10:20. Do you want to take a little break? Yeah. You ready for a break?
Yeah, my hand hurts.
Yeah, we just did a bunch.
All right,
Okay, guys. We will take 15 here. It is 10:20, so we'll be back at 10:35ish. When we get back, we will do a little bit of practice with this, but we're also going to introduce something a little bit different. Okay? So just be ready for that. We'll take a few notes when we get back. This was some good practice. If you want to keep practicing these, you're so more than welcome to. I've got an answer key. We can check more later. But go ahead and take a break. We'll be back about 10:35. We are back from our break, and all of you should have been given a paper with graphs on it. Diane, did I put one over there? Okay, good. Good. So on this paper, you will see the first side has 4 graphs. The back side's got 4 more. So might be a little hint at what we're about to do. We're going to do some graphing. So we just practiced doing a bunch of absolute value equations. We practiced kind of what happens whenever we are setting something equal to an absolute value. Basically, there's going to be a positive version of that answer that exists, and there's a negative version that exists. There's always going to be this kind of two-way split between positive and negative. So what I'm going to have you all do now is we're going to begin a page of notes and talk about what happens when we use more than one variable, because we've only been using just x values here. But on a graph, we have y values also. So I am going to title my notes Algebra 2, Unit 3. And today is day 18. So I'm going to title this as my day 18 notes. Put the date on there again. Let's see. Tuesday. November. You take one for graphing. Absolute value. Moving on to graphing absolute value. And what I'm gonna have you write, begin with, is y equals. And then a big absolute value bar, x minus 8 absolute value bar plus k. Started taking notes.
So,
Yeah, okay. So y equals a times the absolute value, x minus h, close the value plus k. This is going to be our standard form equation for when we graph something. Now, we're going to start by looking at the simplest version of this equation. For that, I'm going to write over to the side. This is just standard form. Underneath this, we're going to just write y equals the absolute value of x. Let's start with the simple one. We call this, in quotations, the parent function. So whenever I have this equation here that says y equals the absolute value of x, we're going to want to talk about what this means on a graph. So we're going to kind of, as we write these notes, be using this graph paper. And right above my very first graph, I'm going to write that parent function, y equals the absolute value of x. So whenever we have absolute value, remember that it's always positive. So let's start by making a chart of points on our graph. Let's plug in some values. We're going to make something called an XY chart. So here's X values, here's Y. And then let's draw a line down the middle. Give ourselves 1, 2, 3, 4, maybe 5 values. Let's choose a random number for x. Let's keep a small value. So between 0 and 3, maybe.
2.
2. Okay, let's pick 2. So whenever x is 2, let's see, what would y be? To do that, let's take this function, y equals the absolute value of x. But let's replace the x with the value we chose. So y equals the absolute value of 2. If y is equal to the absolute value of 2, what would y be?
2.
2. The absolute value of 2 is 2. So, what is my y value?
2.
It's 2. Okay, so there's 1. What's another number we could check?
3.
3. Let's try 3. Actually, hold on. Before we try 3, let's actually also try the negative 2. Let's do a positive version and a negative version. So now we're going to do negative 2 for x. And let's label our work. So this first one we'll call A. And I'll put A over here, so I know that that's how I got 2 and 2. We'll call this next one B. So if I want to find my y value for point B, we'll do the same thing. We're going to start with that parent function. Y equals the absolute value of x. And I know that I'm choosing -2 as my x. So what should I do here? Before we plug in +2 for x, what should I do next?
Give your y equals absolute value on -2.
Yes, now let's plug -2 in for x. So now my y value is going to be the absolute value of -2. What is the absolute value of -2?
+2.
Well, +2 again. So when x is -2, y is +2. When x is +2, y is also +2. So here's what's happening. Why don't we try 3 like you suggested, Diane? So let's make a point C here, and we'll use 3 this time. If my x value is 3, how could I find the y value that goes with it?
Rewrite your equation where you're putting y equals absolute value and then put 3 for x.
Perfect. This time we'll plug in 3 for x.
Y equals 3.
And y equals 3. Good. So when x is 3, y is 3. What about when x is -3? Like a point D. And this time I'll use -3 for x.
It's 73.
My y is still going to be +3. If I plug it in, I'll do that process again. I'm still using y equals the absolute value of x. I'll rewrite it, but now my x is -3. The absolute value of -3 is still +3. So when x is -3, y is +3. Notice how all of our y values are positive, no matter what our x values are. What if we do 0? Do one more. Let's choose 0 for x, and that'll be point E. And this will be the last point you do. Could I find my y value when x is 0?
Put 0 for your x.
Put 0 for your x. So I'm going to do y equals the absolute value of 0.
Wouldn't it still be 0?
It would still be 0. The absolute value of 0 is 0. So when x is 0, y is 0. So we've just made a list of coordinates. We've just made a list of coordinates. Well, that was a lot to write kind of fast. I'm going to leave that up for a second before we move to look at the graph. Pause this. So what we have made here is an XY chart. We basically made a list of coordinates. 2, 2, -2, 2, 3, 3, -3, 3, and 0, 0. So let's pull out this graph that we have labeled as y equals the absolute value of x. And using these coordinates, let's graph this equation. So for point A, remember your x-axis goes left to right. Your y-axis goes up and down. X always comes first. So let's put point A on the graph. My x value is 2, so I find 2 on the x-axis. My y value is also 2, so I go up 2. Here is point A. Let's do point B. Point B, now my x value is -2. So which direction am I going?
Left.
To the left. I find -2 on my x-axis, and my y value is still +2, so I still go up 2 right here. So here's that point B. So we've done A, we've done B. Let's find point C. That's 3, 3. So where do I go to graph that?
To the right.
To the right 3, good. And then up 3. There's 3, 3. That's point C. How about point D?
To the left 3, up 3.
Good. Left 3 for -3, up 3 for +3. There's point D. Now let's do point E. Where is 0, 0 on the graph?
Center.
Right in the center, right here. What is happening with this graph?
The V.
It's making a V shape. What if my x was 1? What would my y be? 1. So I could put a point here too. I won't label it since I don't have that written. What if x was -1? It'd be +1 again. We're just picking the positive version of the number. And we do, in fact, have this nice V shape. So here's where you will want a ruler. Or a protractor, whatever, a straight edge. And we're going to connect these points. Now, our start point is 0, 0. Do not draw a line past that. We are going to make this V shape. It's 0, 0. I'm going to draw an arrow at the end. Over here. Okay. This is what an absolute value graph looks like. We don't have negative y values for this equation. Here's what that looks like. Kind of interesting. And it makes sense because if I choose any other x value, like what if I chose -6 for x? My y value would be +6. It would line up right there. What if I did +6 for x? Your y would still be +6. It would land right on that line. It's going to create a V shape that goes on forever and ever. Kind of interesting. So now that we know this is what it's going to look like when we graph y equals the absolute value of x, this is our parent function starting at 0, 0. How is that going to relate to all this crazy looking stuff? Here's where it gets interesting. We're going to start with one thing at a time. Let's see what would happen if I now did, I'm going to write on the same graph here. What if I do +3 at the end of my equation?
the absolute value of whatever you're putting in for X
Mm-hmm.
and add 3 to it.
Yes. Yes. All you're doing now is adding 3 to your Y value at the end. Now, here's why that is happening. Let's make another XY chart. Okay. So, I am going to right below here, right? Y equals the absolute value of X plus 3. And so it's kind of color coded. I'll put that in blue. Little box around it. This time we'll do X, Y. And how about we use the same numbers and just see how that changes things? So we started with 2 last time. I'll start with 2 this time. And we're using a different equation now, not just y equals the absolute value of x. We're using y equals the absolute value of x plus 3. So to find point A, do the same thing. Y equals absolute value of x plus 3. How can I find my y value for this when my x is 2?
Let's do Y equals 2 plus 3.
Y equals not just 2 plus 3. That is what it's going to end up being.
You put the 2,
Well, yeah,
you plug the 2 in for the X.
Yes, I'm just being
Sorry.
picky. You're okay. So x is what we're plugging in. 2. Y equals the absolute value of 2 plus 3. So this is where it's important to remember the order of operations. What is the absolute value of 2?
2.
It's 2. Bring down plus 3. What's 2 plus 3? 5. So when x is 2, what's my y?
5.
5.
Okay.
What do you think it's going to be when x is negative 2?
-5.
Are our y's ever going to be negative?
Oh,
Oh.
no.
Not in this case, because we're not doing anything negative. We're just adding to it. Because if I plug in negative 2, what's the absolute value of negative 2?
2.
Yeah, positive 2 again. Here, I'll write it out just to make sure we got that. So B, if I wanted to use negative 2 for x, now I'm going to do the same equation. Y equals the absolute value of x plus 3. But this time we'll plug in negative 2 for x plus 3. Thinking back to our expression that we did yesterday, whenever we would have to, like, there was no number we're solving for necessarily. We're just doing it like this. We're simplifying. What do I do now?
Take Y equals the absolute value of negative positive 2.
Yes, the absolute value of negative 2 is positive 2. Bring everything down. 2 plus 3. And what is 2 plus 3?
1.
5.
5.
Oh, you switched it up, didn't you?
Huh? What did I switch up?
From the negative 2 to the positive 2.
Yes, because it's the absolute value of negative 2.
Gotcha.
Yes. So you'll notice
Well, I
whatever.
gotta slow down again.
Yes. Okay, so we have our point B. Let's do 3 for C. Again, using y equals absolute value of x plus 3. What can I do to find y when x is 3?
Write the equation, but put y equals absolute value, positive 3.
Yes. This time we're going to plug in 3 for x. So y equals absolute value of 3 plus 3.
Y equals 3
Y equals 3
plus 3.
plus 3.
So y equals 6.
So y equals 6. So when x is 3, y is 6. Now, what about when x is negative 3?
It'll be 3.
That absolute value of negative 3 is still 3. What's my y value going to be?
Sorry.
You're okay.
Plug in the negative 3.
Yeah. So we have y equals the absolute value of negative 3 plus 3.
Y equals positive 3.
So y equals that absolute value negative 3 is positive 3. What comes down?
Plus 3.
Plus 3. And y equals
6.
6. What do you notice?
That regardless with x being positive and negative in rotation, your answers in y is going to be positive all the way down.
Yeah, we notice that whether I use a positive number for x or a negative number for x, I'm going to get the same number for y.
Yep.
No matter what, as long as the x has the same absolute value. Because the absolute value of 3 is the same as the absolute value of negative 3. So, we're going to get 6 for both y's. Last one, what about 0 for x?
You still write out your equation as y equals the absolute value of x plus 3. Then put y equals 0 absolute value
Y equals absolute value of 0
plus
plus
3
3.
again. Then y equals 0 plus 3.
0 plus 3.
And y equals 3.
Y equals 3. So when x is 0, y is 3. Okay, so we now have a list, an XY chart for this graph, this equation. Y equals the absolute value of x plus 3. See a few people still writing. I'll wait a second before we graph.
Gotcha.
Okay, so now that we've got our list, I'm going to bring this graph back over, and I want to draw my points on the same graph. Okay? So let's start with point A. My x value is 2, my y value is 5. How am I going to graph that?
To the right, 2, up 5.
Good. Over 2 on the x-axis, up 5 on the y. This is point A. Point B, where do I go?
To the left, 2, up 5.
Good. Left 2 to negative 2 for x, up 5 for y. B. How about point C?
To the right, 3, up 6.
Good. To the right, 3 for X, up 6 for Y. That's point C. Point D.
To the left, 3 up 6.
Good. Left 3 up 6. D. Now point E.
To the middle, up 3.
Good. Right in the middle. X is 0. Up 3. So,
Another B.
another V. We can connect our dots, connect our points. Let's see what happens. So, our orange graph was y equals absolute value of x. The blue graph is absolute value of x plus 3. What happened to my graph?
They kind of stacked on top of each other.
They kind of stacked on top of each other. How many spaces did it move?
3.
3 spaces. If we started at 0, let's use this center point here as our starting point. At the end of this equation, it says plus 3. If I start here and I go plus 1, plus 2, plus 3, I land right on the starting point of my next graph. When we have a number being added on the outside, all it does is it moves our graph up. The graph stays the same, but it moves up. Once you have your first point, you can skip doing all the math and just start graphing. Because something else that happens is we notice that there's kind of a pattern to the way that this is actually graphed. We go up 1 space, over 1 space. There is a point. Up 1, over 1. There's another point. Up 1, over 1. There's another point. Up 1, over 1. There's another point. No math needed. You can use some counting skills there. Up 1, over 1, and we get more points. So without doing any math, for my blue equation, what would my y value be when x is 4?
6. Oh, 7.
7. If x is 4, we see that it lines up here with 4. It lines up on the y-axis with what would be 7. We can use that to help us. I think that's kind of neat.
Oh yeah.
Makes it a little easier when you understand things like that.
Yeah.
What if we had minus 3 on the end instead of plus 3?
Wouldn't it go down?
It would just go down. So,
Oh shit.
scared me. So why don't we write that also? I'm going to write below here y equals absolute value of x minus 3. So if my starting point is here in the middle, how many spaces do I move and where?
Over to the 3. The negative 3.
Negative 3. We'll move down 3 this time. So 1, 2, 3. Now we're here. And if I want to follow the same pattern, notice what we said. We said we just go up 1 over 1 in both directions. What would I do to find more points on this one?
Negative 2 over 1.
Yes, up 1 to get us to negative 2, over 1. We can do it again. Up 1 over 1. Do it again. Up 1 over 1. Okay, what if we go back down to that 0? I know that it's supposed to make a V shape. Where should I go now?
Left, up, and over one left.
Yes, up one over to the left this time. Up one over left one. Up one over left one. Up one over left one. We just shifted our graph down this time.
Good.
We can connect our dots. Yeah,
That's cool.
that is cool. When we have plus or minus a number at the end, outside of the absolute value, it moves our graph up and down. That's all it does. It moves it up and down. So that's interesting how it does that. Kind of neat. So if you want to label this a little better, I might write over here on my orange line that this was y equals absolute value of x. That's all it was. There's nothing added or subtracted. My red one was absolute value of x minus 3, so we moved down 3. My blue one was plus 3, so we went up 3. Okay. So, something we can make a note of. Let's see. Can I move this graph? Anybody still copying it? Okay, I'm gonna move it. Something we can make a note of is when we go back to this standard form equation, let's ignore the a and the h. And now I see y equals the absolute value of x plus k, right? That plus 3 and that minus 3, those were like values for k. So whenever I have plus k, I move k spaces up. When I have minus k, I move k spaces down. So I'm going to do this. I'm going to circle this k here. Right. Plus k up minus k. Graph paper.
And this is saying like that this positive moving going up and negative
Yes.
going down.
Yes, yes. So let's look at another equation that we could graph. I'm going to write y equals the absolute value of x plus 2.
Well, I was gonna ask you, so is every one of these graphs, are they gonna always form a B
Yes,
every single
Every
time?
single time.
No matter what equation we have?
it will. Every
Okay.
single time.
Mr.
Uh-huh.
have whiteout.
I do. Thank you. Okay, so let's start this next one here. Absolute value of x plus 2. So if my starting point is 0, let's think of the starting point as being right in the middle of the graph at 0, 0. What does this plus 2 tell me that my new starting point, thank you, will be?
At 2, positive 2.
At positive 2. We're going to move our first point up 2 spaces. Right here. Now that I know my starting point, what's the shape of my graph going to be? How do I find more points without doing math?
It goes up, the plus 2, right?
Say that one more time.
I said it goes up because the plus 2, right?
Yep, it goes up. We moved our first point up 2.
You keep going up 2.
You go up 2 over 2.
You could do up 2 over 2. You could also just do up 1 over 1. Same thing. Up 2 over 2 would be just like doing up 1 over 1, up 1 over 1 again. You can just do up 1 over 1 though for this every time, just up 1 over 1. So up 1 over 1 from my start point. Up 1 over 1, there's another point. I can do that as many times as I want. Up 1 over 1. This is like if you remember back in Algebra 1, this is your slope. Rise over run. Up 1 over 1. Up 1 over 1. And we'll start back at that 2. Now go the other way. Up 1 over 1 to the left. Up 1 over 1 to the left. Up 1 over 1 to the left. Up and over again. As many times as you want. Up and over. The more points you put, the more accurate your line is going to be. Because if you just got more little points to go through. So we will connect our dots. I want to make some sort of note to help you remember why are we starting at 2? We have plus 2 here. So what's happening is if we start at 0, we have plus 2 right here. What we're doing. We're just moving the start point up 2 spaces. About y equals, I draw one down here, absolute value of x minus 5.
Start at 0 and -5.
Start at 0. Since there's minus 5 at the end, we'll go down to -5. Yes. So because it says minus 5, we're going to start down here at minus 5.
So the G always goes up.
It will always go up unless we have a negative on the outside, but we're not going to do that today. We'll wait. Okay, so I have my starting point. I went down to minus 5. What do I do now?
Are you still doing the 1 up and 1 over?
Yes, we are. So, up 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. You can do it as many times as you want. Have at least 2 points, but the more you do, the more accurate it'll be.
Yeah, she was telling us in Algebra 1, you know, have a minimum of 3, I guess.
Yeah,
3,
yeah. Have a
be-
minimum of 3. So I would like you to have that first point and then 2 more on this side at least.
yeah.
And then go back to that first point, 2 more on the other side. So I guess the minimum is 5 points on this.
Well, no, not the V. I'm talking about as
Oh, on a straight line?
yeah,
Yes,
yeah.
3 points is a good minimum to have. I used to tell you 2 points, but 3 points is better. Okay, so now I've gone up 1 over 1 all the way to as far as I could on the right side. Now what?
Do the same thing on the left side.
Same thing on the left. Up 1 over left 1. Up 1 over left 1. Up 1 over 1 to the left. Up and over. Over. Do not need this many points. But it helps. Connect our dots.
Okay, I have a question.
Yes.
Because we don't know the absolute value, is that why we start at 0? Because it's x and it's not a number?
Because it's X and it's not a number. Can you ask that again? Because
Is that why we start at 0?
is that why we start at 0? We're starting at 0 because in this equation, if I plug in 0 as my starting point, the absolute value of 0 is always 0, so I'll be left with a -5 no matter what. 0 is a really good starting point.
Oh, that's the Y. Okay.
Yes, because it gives us our first y value right away. If x is 0, it gets rid of x. Then I just have y as -5. So that's why we start at -5 on the y-axis. Does that answer your question?
Yeah, I was confused.
Okay, perfect. Perfect. Okay, so let me just. Okay. Okay. So we just graphed that. I want to see, do we want to run through another one together or do you guys want to try one on your own?
Good question.
Do we want to see another example first?
Yes.
Okay, let's do another couple. Make sure. Can I move this? Does anyone still need to see it? You're fine. You're fine. Okay, let's try y equals the absolute value of x -4. Okay. What is my first step? 0.
-4.
-4. Where? On my x-axis or y-axis?
On your Y.
On my y-axis. When x is 0, y will be -4. So let's go down to -4. Okay. And this is my starting point. Now what?
Up 1/1.
Up 1/1.
So do we always go up 1/1?
Yes, you always go up 1/1 unless there is some other number that tells you to do something different. Today we're not learning about that other number. We're doing one little thing at a time. So for today, you're always going up 1/1.
Okay.
Eventually, we'll talk about when you do something different. Today, just worry about up 1/1.
We always start off going to the right first.
You can do left first if you want. I'm just in the habit of doing right first.
Right. Yeah.
So I've got a couple of points over there. What do I do now?
Do the same thing on your left side.
Same thing on the left side. Up 1, over 1 to the left. Up 1, over 1 to the left. Up 1, over 1 to the left. I could make as many points as I want. I'll leave it there. And I'll just connect my dots. That's not too bad, is it?
No.
No.
Not too bad.
Once we got our starting point. I mean,
Yes, once we start to see what happens, how patterns work, all we have to do is follow that pattern
Yeah.
and use some little shortcuts. You don't have to work out every single problem. You know how in the last unit we solved, or I guess this was unit 1, we solved systems of equations by graphing on our calculators. Your calculator can graph these too. Kind of cool.
No way.
Yes way. Yes way. Yes way. So you
Yeah.
can check your work on a quiz
Yeah.
if you have to graph
Double
something.
check yourself. That'd
Yeah.
be cool.
I know. Okay, so there's y equals absolute value of x -4. We kept the V shape, but we moved it down 4 spaces. Can you try one on your own now? I think you
Yeah.
can. Okay.
Yeah.
I want you to do y equals the absolute value of x -1. And if you finish that, on the same graph, I'm just going to draw a line to separate. I'd like you to also do absolute value of x. 4. Did we already do that? -4 was +4. Okay, so do the absolute value of x -1. If you finish that, try the +4. I'll set a little 5-minute timer here. And we'll check our work, see how we do. Okay, so we've had some couple of minutes here. let's see what the graph of y equals the absolute value of x minus 1 should look like. Who can tell me where to start?
You go to the -1 at the bottom of the line, so.
Okay, so I see that I have minus 1. So when x is 0, y is going to be -1. We just go down 1. Okay, what do I do from there?
Up 1/1 to the
Up
right.
1 over 1 to the right. Do up 1 over 1 again. So I've got 3 points here. Now what?
Do the same thing on the left side.
Same thing on the left side. Up 1 over 1. I'll do up 1 over 1 again. 5 points there. Now, let's practice labeling these points. I want to make sure we can label our coordinates. Go over to the side. I'm just going to make a little XY chart. And let's label our points. A, B, C, D, E. And we'll start from left to right. We'll make this A. Right here. What would point A be labeled as?
-2, 1.
Good. -2, 1. How about B?
Negative, or 0, -1.
0 for X.
Or no. Yeah.
If X
No. -1, 0.
yes. X is -1. We don't go up or down, so Y is 0. So -1, 0. Point C. X value. 0. My Y value. Good. 0, -1. Point D.
0, 1, 0.
1 for X, 0 for Y. Good. And E.
2, 1.
Over 2 up 1. Yes. 2, 1. Okay, so everything is labeled. And if we label them from left to right, where our starting point is right in the middle for C, then our XY chart will come out to have a sort of pattern where it goes 1, 0, -1, 0, 1. They mirror each other. -1 being that center point, and then the next ones on each side are 0. The next ones on each side are 1. Just like the graph mirrors itself. So, that is our graph for the absolute value of x minus 1. That. How about the next one? Absolute value of x plus 4. Start at 4. Start at 0, 4. And then what? Up 1 over 1. Up 1 over 1. Then what?
Same thing on the left side.
Same thing on the left side. Up 1 over. Up 1 over. There we go. Go. So my middle point here. What's this coordinate?
0, +4.
0, 4. This time we'll label it with coordinates like this. 0, 4. How about the one next to it to the right?
0,
5.
5.
Is it still on 0 on the x-axis?
1, 5.
1, 5.
Now it's
I'm sorry.
1, 5. Good. 1, 5. What's the next one?
2, 6.
2, 6. How about the ones to the left? This one here.
-1, 5.
-1, 5. You see the pattern? Last one here.
-2, 6.
-2, 6. There we go. So there's two different ways that you can label your points. You could make an XY chart and label A, B, C, D, E, or you could write all the coordinates and point to your points like this. Either way, I'm fine with. But we do want to get in the habit of labeling our points. Okay, and you can do this with the graph instead of going through and solving 5 equations for y. Sometimes the graph is a little quicker. I think they got that. Up 1 over 1, and then you just move it up if you're adding a number at the end, or you move it down if you're subtracting a number at the end. I have an exit ticket for you. Mm-hmm.
For me,
For you. Sweet. So, I am going to run copies of it, but if you are wanting to go ahead and start on it, before I make copies, I'm going to put this here. For your day 18 exit ticket, I want you to graph this absolute value equation. And on your graph, label your coordinates. You can either do an XY chart. I went ahead and made one for you. Or if you don't like the XY chart, you can just point to all your coordinates and put them in parentheses. You do need 5 points. 5 points. So I'm going to freeze this on the screen so you can see it, and then I will run some copies of this. This is due on Friday. Friday, November 7th. Let me freeze this, and that will be all for today. Yay.